Good day. Today I will be demonstrating my speed reference unit. It is made up of many sub-circuits connected, such as the LM35 and ADC connection, the digital user interface, the cascading comparators, and the logic gates. Let us start off by going to the LM35 and ADC sub-circuit. Let us set the temperature over here on the LM35 to 10. Now, this is the temperature being picked up by the temperature sensor. In order for the ADC to pick up this, first, as you can see, it outputs 10 millivolts. This is because for every degree Celsius measured over here, it outputs 1 millivolt. To fix the step to ensure that the binary increases with every millivolt received, we adjusted the VRF over 2 by adding 1.28 volts. To update the value being output, we press the button. Now we have 1010, which is 10 in binary. This value will be sent to the speed measurement unit to be displayed. 8 bits was used because it allows us to go up to 256, which is more than enough for recording room temperature. Let us move to digital user input. Let us focus on just the lower bound. The lower bound and higher bound are identical, with each containing two 7-segment displays, two decade counters, a 555 timer circuit, and a binary ripple counter. Let us move this to right. The user sets the value of the lower bound manually by pressing the left button. It increments each time. Let us set it to 5. Now the lower bound is 5. If we wanted to reset it after making a mistake, we'd press the right button. As you can see, 5 is also output on the binary ripple counter. The decade counters are used to display the values onto the 7-segment display from 555 timer, whereas the binary ripple counter is used to output the binary value of the input to be compared at the cascading comparators with the room temperature. Before we get to that, let us quickly just set the value of the higher bound. Let us set it to 15. Right. Now let us move to the cascading comparators. The cascading comparators first compares the higher byte of the room temperature with the higher byte of the bound. In this case, we are looking at the lower bound. Once it is compared there, it moves and compares the lower bytes of the room temperature with the lower bytes of the bounds. These outcomes, A is greater than B, A is equal to B, and A is less than B, lets us know how the temperatures, what the outcome of comparing the temperatures would be, with A being the room temperature in binary and B being the bound in binary, in this case the lower bound. As you can see, the room temperature was greater than the lower bound. The same thing happens over here. The values are then taken to the logic gate. There will be 6 values. These 6 values will be then compared to each other. Here they are listed. Temperature less than lower bound, false. Temperature less than higher bound, true. And so on. In this case, we chose a value that's in between the bounds, which should give us an output that will signal the motor drive unit to output the motor's value at a medium speed, and as we can see, temperature is less than higher bound, temperature is greater than lower bound. They are both true. Therefore, we get an output of 1.64 volts. As we can see here, the reference voltage to be sent to the motor drive unit will either be 1.4 volts, 1.64 volts, or 1.96 volts. This is to signal for a low speed, medium speed, and high speed. Let us do a test to demonstrate the outcome for low speed. We'll start off by just updating the temperature. Let us make it something below 5, like 3. Once we change the temperature, we need to update the reading by pressing the button again. Now we have 3 in binary, 0011. Now the bounds stay the same and the comparators do their job automatically. So we can just move and go see the outcome for ourselves at the logic gates. We've got temperature less than lower bound, temperature less than higher bound. This will give us an output of 1.4 volts, which is for low speed. Now let us test for high speed. Example. All we have to do is make the temperature greater than 15. Let us say we make it 17. We once again update it and then go to the logic gates. We should expect the output voltage of 1.96 volts. And there we have it, 1.96 volts. That is the demonstration of my speed reference unit showing outputs based that give us showing outputs for low speed, medium speed, and high speed. Thank you for watching my video.